Good morning, everyone. I'm introducing a new assignment. It is probably the last assignment for this lesson. So this is called ideal gas law. The equation for the ideal gas law is right here. P times V equals N times R times T. P stands for pressure, V for volume, and N is the little lowercase n is moles, R is a constant, the value should be given to you, and T is the temperature. Now, this equation is also known as combined gas law, where so many scientists gave their own relationship between pressure, volume, moles, and temperature, and those relationships were put together in one equation. What that means is if you are given a set of variables, you can find the unknown variable using the other given variables. Let's take a look. Let's dive into the question right away. So this question number one, the value of P is given as 1.01 atm. Volume is question mark unknown. N is the moles. That value is given, and temperature is given in 25 degrees Celsius. Now I have to tell you that all in this particular equation, the easiest way to solve this equation is if you have the right units. Pressure should be always in atm. If it's not, you can use this equations to convert your pressure into atm. Temperature should be in Kelvin. If it is in degrees Celsius, you can turn it into Kelvin. I'll show you how. Right now it's 25 degrees Celsius. To turn the temperature into Kelvin, you have to add 273 to your value. So I'm going to add 273 to 25 degrees Celsius, and that gives me 298 Kelvin. So now we will use Kelvin. We will not use 25 degrees Celsius. This is our equation. Pressure times volume equals N moles times R. R is also known as Rydberg constant, and T stands for temperature, which should be in Kelvin. Now we are looking for V. V is our unknown. We will isolate V. That means we should be alone on one side, and the partner, whoever is next to it, should move to the other side. So pressure, since it's multiplying the volume, when it goes to the other side, it is going to divide. So I have to write a modified equation, which is now V is alone by itself, and whatever we had on the right hand side stays as is. Now the pressure that was on the left has moved to the right, and now there is a divide sign. So we have volume equals N times R times T divided by pressure. We have to just plug in values. So volume will be equal to 0.00831, that's the number of moles given, um, times R. R is 0.0821. Coincidentally, the value of moles and R happens to be very similar in this question, but R is always going to be 0.0821 for all your questions. Sorry, I deleted it. 0.0821 times temperature. What is our temperature in this question? 298 Kelvin divided by pressure, which is 1.01. And let's see what we get in the calculator. I'll do it in front of you. 0.00831 times 0.0821 times 298 divided by 1.01, and you get 0.2. It's a big decimal number. I'll just take it up to 2 decimal numbers. So your answer is the volume is going to be 0.2. We don't have to put 0 after the decimal point, liters, and that would be the final answer. So this is how you're going to solve all the questions. There are 5 variables. 4 of them will always be given to you, and the 5th one you will have to solve for. The challenging part is how to modify this equation, which if you need help, we will have Google Meets this week. so I can help you with this modifying part of the equation. But other than that, it's pretty straightforward. It's a cross multiply, and you just answer the questions. I am taking off the answers from here so that you can solve it by yourself and see if you get the same answer. I hope that helps. And if you want me to solve more questions, I will do it in Google Meets. And if you want to have an independent meet with me, we can do that. Also, I'm giving the answers to all the questions. So, what am I grading you for if I'm giving you the answers? I'm actually grading you for the work that you are going to do. For all the questions, I have given the answers in a format. So for givens, make sure you put all the givens down with the units from the question. Equation, I've already given it to you. The modified equation, you will modify it and write down the modified equations. Values, after the modified equation, you put in the values and show me how you're putting in the values, and then the answer. So this process has grades, not the real answer. And this actually helps. So I'm not, even if I'm not in front of you, the correct answers would guide you if you are going in the right direction. There is nothing new to it uh, besides the equation. Make sure the temperature is always in Kelvin, and pressure should be in atmospheres, ATM. Volume should be in liters. How about I just write that down for you? Pressure, the units should be ATM. Volume should be in liters. Temperature should be in Kelvin. And anything else? That's it. So, make sure you do those conversions. And I have these two charts. You have done two assignments on it already. If you want, I can help you with the pressure problems where the pressure is not given in ATM. Like question number 5, I'm going to copy down these values. So moles are given 0.5. So for moles, I'm going to copy and paste it down here. Pressure is 98.4 kPa. I'm going to copy it down, copy and paste it down for the pressure. And temperature is given 11 degrees Celsius. That goes next to the temperature, which I have to add 273 to it to turn it into Kelvin. So 11 plus 273 gives us 284 Kelvin. You can do that in the calculator. R is a constant, which I'm giving in all the questions. It's already provided. And the question says what volume. So V is our question mark. Now, the equation is also given in this here. The modified equation is similar to the question number 1, which I solved before. So volume is equal to nRT divided by P. Because volume is unknown, I have put it alone, separate, isolated. And pressure, the P moved to the other side and it's dividing. So now I'm going to plug in the values. Volume is equal to, I cannot use kPa, I have to turn it into ATM. So what I'll do is I'll go up here on the top of the page. kPa, the constant is 101.3. So I will divide the question value by this constant to get the answer in ATM. So question number 5 down here, I am dividing it by the constant 101.3. And this will give me my answer in ATM. So 90, I'll do it in front of you. 98.4 divided by 101.3, that gives me 0.97. I'm going to leave it at that, just two decimal places. And now I'm going to use ATM in my equation. Do not use any other units for pressure other than specified, because this constant R is dependent only on these units. If you do not use these units, then the R is not going to be 0.0821, it will change. So in order to keep our R as the same value, 0.0821, we are using the specific units for all the variables. So let's just plug in values. N is 0.580. I'm just copying these values down from the above givens. R is 0.0821 times, it's going to be the temperature 284 Kelvin divided by pressure, which is 0.9 7. I'm going to do this question right next to you in the calculator. 0.580 times 0.0821 times 284 divided by 0.97, and the answer comes out to be 13.94, and a big decimal number. I will round it up. Volume is equal to, I will round it up to two decimal places, 13.94 liters, and there you go. That's all you have to do. I hope that helps. I helped you solve two questions, and I'm erasing the work from here so you can see it for yourself. And here my answer, look, the answer given was 13.9 liters, and I showed you how to get 13.9 in the calculator right here. It's only possible if you are using the correct units, and make sure you convert it into the correct units. Um, that's pretty much it. Um, Now I'm going to talk a little bit about the ideal gas law and applications in the real life. So you'll be like, why are we even doing this? How does it apply in chemistry and in our lives? So this is Gay-Lussac's law. I know you're gonna laugh at his name, but this guy actually helped us develop the hot air balloons, where you increase the temperature inside the balloon, and what effect does it have on the pressure? So as you increase the um, volume, the pressure is directly related to the temperature. Increase the temperature and you increase the pressure, so the gas balloon gets really expanded and it has a high pressure and it rises. So with this law, the gases behave according to the ideal gas law. Ideal gas law is a combination of three different scientists and their laws: Boyle's law, Charles' law, Avogadro's law. You put them together and you come up with this equation: PV equals nRT. It's not one person's equation, many scientists came up with this equation. I will show you another application: the fridge. It does cooling. And how does it do cooling? By using the gases. The coolant gas is a special gas that is put in the refrigerator, and that gas is highly compressed. Compressed means the volume is really really low, it's in a very tiny space, and the effect of volume is on the temperature. So if you compress a gas, the temperature will increase. So in order to cool the gas, you have to make the volume bigger. So the expansion and compression makes the gas temperature rise and fall down. So that's another application. Air conditioners, refrigerators, they all work with the gas laws. I hope the gas law equation is easier, but I will have Google Meets this week in case you need more help on the ideal gas law. Take care, guys. Bye bye.